Hi everybody, it's Jeff again, and we're going to work on another modeling project today. I think I mentioned at the end of the last video that I wanted to get into some of the more advanced techniques in modeling that come up when you're trying to do precise designs. So for example, if you are designing a part that's going to interface with something that already exists in the real world, you have to be really careful in your placement of the features of that part to make sure that they line up with the thing that you're interfacing with. So an example would be a motor, and that's going to be our example that we're going to work with today. This is a little servo motor. These are used in model airplanes and robotics and all kinds of things. These are very inexpensive. And they're useful on their own, but if you're going to use this as part of a robot design, you're going to need to hold it on to your robot somehow. So we're going to design a mount for this. Now, if you look up a 9-gram servo on the internet, or a micro servo, you can find dimensional diagrams that'll give you an idea of the scale. We're going to take some measurements in a minute, but they usually have mounting holes on these little ears that stick out from the sides. So when we model a mount for this, we're going to have to make sure that those holes line up. And to give this thing good support, we're going to want to design our mount so that it sort of cradles the part securely. We want the cradle to do most of the support, and the screws, which are usually very small screws, are just really going to kind of hold this in place. They're not going to have to take a lot of weight. So to design this mount, we're going to have to take some careful measurements. We're going to have to take some notes, maybe make a sketch first. I mean a pencil and paper sketch, not a sketch in Fusion. Now, that may sound kind of old school, but when I'm getting ready to do a design, there's usually a bunch of measurements and a bunch of other details. And I find it helps me to sort of visualize what I want to accomplish if I draw it out or sketch it out first and write down those numbers. It just makes the process go a lot more smoothly. What else are we going to cover today? We're going to cover a few other things you're going to need to know for more complicated modeling. Things like construction geometry. And also, we're going to talk about part revision because, well, you're going to see it as we go through this. I'm doing this sort of off the cuff. I haven't done a lot of careful design. I've taken a couple of notes, but I haven't done a lot of planning for this session ahead of time. We're going to go through it together, and I can guarantee you I'm going to make a mistake at some point. We're going to have to go back and revise it. And that's, here at LoisLab, we celebrate our mistakes. We laugh at them, we learn from them, that's how it goes. So I'm not worried about making mistakes here. What's more important is that I know how to go back and change it and correct it so that in the end we end up with something that's very successful. So that's something else we're going to go through today. So I'm going to set up the camera to take a look at my notebook. We're going to take some measurements and we're going to do a quick little sketch. And that's going to be our starting point. And then we'll get into Fusion and actually start building a mount for this servo. Okay, so the first thing we need to do is get some measurements of our part here. If you didn't get a good look before, this is a little 9-gram servo. Got a couple of mounting holes on the sides. So I'm going to do a quick sketch of this part. And, I'm not a very good drawer, but for this kind of work I don't need to be. Really what we want to do is just sort of represent the dimensions of this part so that when we go to use those dimensions in our modeling process, we've got them at hand. So I'm using a set of calipers here. These are inexpensive calipers. You can get them on Amazon for maybe 15 bucks, 20 bucks. We've got several sets here at LoisLab for you to use as well. And they make this job really easy. So let's see, get an accurate measurement here. We've got about 23 millimeters is the width of the part here. We want the overall height of the box section. It's about the same. That's closer to 22.5. So that's right here, 22.5. We're going to want the dimension underneath the mounting ears here. That's going to be an important dimension. If you're not familiar with using calipers, if you're using an inside measurement, you can use these kind of ears on the back. It's about, call that 18. And if you're doing an outside measurement, you can use, between the regular little prongs here. Just make sure you get it nice and square. You can also use this section up here where they're flat and get a slightly more accurate measurement. Now, a tricky bit, let's draw the top-down view. And when you're looking at the servo from this perspective, we've got, the actual geared part that actually does the work, and then we've got the mounting hole here and the mounting hole here. Now, if you've ever tried to measure the distance between mounting holes, you know that it can be a little bit tricky. The important measurement is the center to the center of the mounting holes, because that's how we're going to draw it. So we need the diameter of those holes to make sure the hole is big enough for our screw to fit into, but we also need to know the center to center distance between those two mounting holes. But we want this to fraction of a millimeter accuracy, and getting, eyeballing the point of one part of the caliper to the point of the other end of the caliper on the centers of the holes is really fussy, okay? So there's kind of a trick. If you think about it, the center to center of the mounting holes is the same as the edge to the edge, if you're talking about the same edge. And what I mean by that is, if I go to the left edge of the mounting hole and then measure to the left edge of the other mounting hole, that is the same dimension as the center of the hole to the center of the hole, assuming that the two holes are the same size. So once again, rather than trying to balance the caliper and eyeballing when I'm at the center of those mounting holes, I can just slide it over and measure from the edge of the mounting hole to the other edge of the mounting hole, and that's going to give me the dimension that I need. So to me, that's looking like 28 millimeters. Just write that in here. And then it looks like I also haven't measured the thickness side to side, and that's about 12 millimeters. So that's this dimension right here, 12 millimeters. So that didn't take too long, but this should give me all of the dimensions that I'm going to need in order to make a mount to hold this part. I've decided that I'm going to do one more little sketch here, and that is going to be a sketch of what I think the final part is going to look like. Now, I think I mentioned before, I'm not a great drawer. This really just has to be enough to help me sort of visualize what's going on here. What I'm going for is a part that's going to cradle the servo. And what that means is I want it to wrap around the servo and give me a place for the mounting holes to be. And we also need a mounting flange that's going to allow it to attach us to another part, whether that's maybe the body of a robot or something like that. So again, I'm not the best at drawing perspective here, but you can kind of see the idea. The servo will sit down into this pocket. These mounting holes will hold the servo in place, and then these holes out here on the flange, and there's going to be another pair over here that you can't see because the flange is hidden by the rest of the sketch. These will attach it to whatever machine we're building here. So since I've already got my little sketch with all the dimensions here, we can plug in the numbers. We know what the size of this inside pocket is because we've measured the size of the servo, and we know the distance between the two holes because we've measured that over here on the servo. So now we should be able to go over to Fusion and start plugging in all these numbers and putting our model together. Now, like we did in the previous exercises, I'm going to start by creating a new component. And I'm going to save this design. We'll call it servo mount. And now we're ready to get started. So let's start a new sketch, and we'll do it on the XY plane, just like we've done in previous designs. And in my sketch, you might remember that we're designing a part that's going to wrap around the servo. And so I think what might be useful is to first start by drawing a rectangle that represents the size of the servo, and then we can build the part around it. So we're trying to build that first sketch that we're going to extrude into the body of the servo mount. So I'm going to choose my rectangle tool, and I'm going to draw a rectangle that is the footprint of the servo if I'm looking down on it. So that's 23 millimeters wide and about 12 millimeters thick, or well, you'll see when you see on my screen here. So 23 millimeters and 12 millimeters. Now, I'm going to roll the dice a little bit here. Now, I'm using a 3D printer that I know is pretty accurate. And so I'm going to print this part at the end and we're going to test the fit. I'm pretty confident that if I make my part sized properly to fit the exact dimensions of the servo, it's going to be pretty close. It might be a little tight, but if you're using a 3D printer where you don't have that same confidence, you might have to print a test piece, test the fit, and adjust it. Or if you know that it tends to be off in one direction or another, you can try to accommodate for that in your design. Sometimes with this printer, interior holes tend to be slightly undersized, and so I'll add an additional tolerance of maybe 0.5 millimeter or something like that. But for now, especially as we're working through this process together, I'm going to trust the printer and I'm going to make things true to dimension, and we'll adjust them in a revision if we need to. Okay, so the rectangle that's on the screen now represents the size of the footprint of the servo. And I realize now that when I was doing the measurements a few minutes ago, I forgot to measure the dimension between the body of the servo here and the edge of the ear, so like the overhang of the mounting flange. I'm going to measure that now. That's 5 millimeters, and I'm going to make that the thickness of the mount as it wraps all the way around the servo. So going back to my screen here, I'm going to use the line tool. Shortcut for that is L, but you can find it up in the Create menu. And I'm going to start a line at the corner of the servo. I'm going to come out by 5 millimeters. Now notice it's giving me an indication, that little right angle indication on the screen. That means I'm coming out at 90 degrees. That's where I want to be. Freeform line drawing shapes in Fusion, it's a perfectly fine thing to do, but you don't have the safety net you have when you're using the rectangle tool where you know everything is going to be true and right angle. If I am sloppy and I draw a line without snapping with that right angle indicator there, my part can end up being crooked. So I'm going to be kind of conscientious. I'm going to come up to this point here. I'm using my little snap indicators. You can see I'm drawing across to get those indicators. That's 12 millimeters. I'm going to continue on up to 17 millimeters because that's going to give me 5 millimeters beyond the back of the servo. I'm going to click again to continue that line. I'm going to come across to here would be 28 millimeters. I'm going to continue on to 33 because that's going to give me my 5 millimeters past. I'm going to come down, again making sure I'm at 90 degrees, coming down to that baseline and then across. And you can see when I finish that set of lines, I've got a 5 millimeter wraparound of the rectangle that represents the footprint of the servo. And when I finished it, it shaded it in an orange. So I know that that's a closed shape. Now, at this point, I can stop and extrude this to make the body of the servo mount, and that would be a good thing for me to do. But referring back to my drawing, I've got the flanges that exist way down on this base plane as well. And I could draw those in this sketch. I'm not going to do that. I'm going to add those later as a separate operation. When we're designing a part and we know that we're going to be doing revisions and iterations later on, I try to keep my sketches constrained to one major feature per sketch. That way, in my timeline, everything is organized very neatly. I've got a sketch for the main body of the mount. I've got a different sketch for the mounting flanges. I'm going to have a different sketch for the mounting holes. All of these things will be separated, which is going to make them neatly organized and easier to revise later on. So I'm going to hit Finish Sketch. It's going to take me back out to my 3D view. I'm going to hit E for Extrude, and I'm going to select the wraparound part of the mount. I'm going to ignore the inner rectangle for now. And I'm going to extrude this up to a height based on the measurements that I took. We know that the servo is 18 millimeters tall under those ear flanges. So I'm going to go up to 18 millimeters, and that should give me the support that I need to set the servo down in and not have it bottom out on the bottom of the mount. I'm going to hit OK, and we've got the first part of the servo mount done. Next, I think I'm going to try to locate those mounting holes. So I'm going to go up to the Create menu, and I'm going to do a new sketch, and I'm going to do this on the top surface of my mount. Now, I'm going to locate these holes in a slightly different way than you've seen me work before. I'm going to draw the two holes first, and then I'm going to use measurements or constraints to locate them. Actually, not constraints. I'm going to use dimensions to locate them. So I'm going to go to the Create menu, choose Center Diameter Circle, and I'm going to draw the first mounting hole roughly in position. Now, to size this hole properly, I need to measure the mounting screw. So I'm going to go into the mounting hardware bag and find the little screws that they provide in order to attach the servo. These little screws with little flat heads on them. I'm going to measure the size of this screw. It's a 2mm screw, but I need to slightly undersize this so that the threads of the screw have something to grip into. So I'm going to make 1.5mm holes. So back to my screen here, I'm starting to draw my circle. I'm going to type in the 1.5mm diameter. I'm going to use the hotkey, draw another circle, and put another circle at 1.5mm on the other side. So I've got circles that are the correct dimension, but they're not located where they need to be. So how am I going to do that? I'm going to use the dimension tool. I'm going to go in the Create menu down to Sketch Dimension. The shortcut for that is D. And I'm going to set my first dimension that determines the distance between these two holes. So with the dimension tool, I click on the center of one circle and then the center of the other circle, and I drag the mouse down. I click a third time to set that dimension, and it's going to ask me what the distance should be. If I refer back to my sketch, I can see that they should be 28mm apart. And it looks like I actually got very close to that just sort of by accident. But I'm going to type in 28mm. And now you can see that those holes are evenly spaced 28mm apart. So that's a good first step. But I also need to make sure that these are located in the right place so that the servo sits in the pocket correctly. And I think the correct dimension there would be to set these holes at the proper distance from the back edge of the pocket where the servo sits. So I know that these holes are centered on the ears. So I should be able to set them the correct distance, and that would be half of the width of the servo away from the back edge of that servo. If the width of the servo is 12mm, I'm just going to check that. Yep. I should be able to space these mounting holes 6mm out from that back edge. So I can do that again. I've still got the dimension tool selected. I'm going to choose the back edge of the servo pocket. Click that. I'm going to click on the center of one of the two holes that are now linked to each other. And then I'm going to click a third time to set that dimension. It's going to give me the option to fill in the number. I'm going to type in 6, and that's going to place it in the right spot. So that's fine. I've got the distance between the holes set, and I've got the distance from the back edge of the pocket set. But is it fully constrained? Is the position of those holes really constrained? Well, you can see that if I click on one of these circles and I move it, I can't move it up and down because I've got a dimension or a constraint set there. And when I move one hole, the other one moves with it because we've got another dimension that's linking them together. But I can still move it side to side, and that means that these holes are not fully constrained. So I'm going to set another dimension that's going to locate them left to right at half the distance of the edge of my mount. Now, I remember when I drew this that I made the width of that part of the mount, which I've clicked on here on my screen, 5mm. But if you ever forget, you can click on a line like that. See this line across here? I can click it to select it. It gives me a measurement down here. It tells me that it's 5mm long. So what that means is I want to locate the center of this circle, half of that distance in from the inside edge, or the outside edge, but I think the inside edge is a more critical dimension here. So I'll go back to my menu, I'll choose Sketch Dimension, I'll click on the inside edge, and I'll click on the center of the circle, I'll drag it up, and set that dimension at 2.5mm. And now, I can check that the location of these circles is fully constrained by clicking on one of them and trying to move it, and it doesn't let me. So that's fully constrained. I've got holes that are the proper size, and they should be located in the right place in the flanges. So I'm going to hit Finish Sketch. I'm and go back to my three-dimensional view. Now you can see those holes here. I'm going to extrude them. I'm going to hit E for extrude. I'm going to select them both. The depth here is somewhat arbitrary. I could measure the screws. I know that they're about 7 millimeters long, so that should be fine. And so as I draw the extrude operation down into the body of the mount, you can see that it changes the operation to cut automatically. I can hit OK, and I've created those holes. So that really illustrates how you can use the tools in Fusion to carefully locate features in a design, and how it's important to fully constrain them. When we get back to revising the parts later on, it'll illustrate better why those constraints are important to revision. Okay, so moving on, let's add the flanges, the mounting flanges, to this design. So I'm going to do that by creating a new sketch. I'm going to create it down on the base plane again. And the mounting flange for this part is going to be somewhat arbitrary. This isn't mounting to, say a robot design or something that already exists. And so we'll assume that we'll create the flanges with mounting holes, and then the rest of our design will be derived from this part. So that's sort of a convenient fiction that I'm creating here. So let's add a 2-point rectangle. I'm going to draw it coming off of the front corner of this piece. And it's going to be, I'm going to make it a little wider to give myself plenty of room for the mounting holes. I'm going to make it 7 millimeters wide, and it's going to be the full width of my, my servo mount here. And I'm going to add a couple of mounting holes. It's going to be the same as we did before. I'm going to draw the mounting holes first, and then I will locate them where I want them. So I typically use M3 hardware. So I'm going to make these slightly oversized for 3 millimeter hardware. So 3¼ millimeters. Actually, I'll make it 3½. 2 mounting holes. Do another one here. And I'm going to use some measurements to locate these holes. I'm going to move the hole in. I'm going to make it actually 3. Yeah, that's a little close. Let's make it 4 millimeters in from the edge. We'll make it 4 millimeters in from this edge. So it's closer to the mount than it is to the edge. I want to leave enough material around the mounting holes so that I'm not worried about the flange breaking. And I will add those same dimensions down here for this other hole. That looks pretty good. And let's see. I'm going to go ahead and add those same features on the other side here. Actually, I'm going to show you an operation that I find rather handy when doing symmetrical features on a part like this, and that's the mirror operation. So let's take a look at that. If we go to the Create menu and we go down to Mirror, we can see a pop-up tip, and it says mirrors the selected sketch curves about a selected sketch line. So we have some sketch lines and curves, and we're going to mirror it on the other side of a line, but that line needs to be at the center point. So we're going to need to create the center line that we're going to mirror around. Okay? To do that, we're going to use something called construction geometry. So I'm going to do that by creating a line. Let's create the line first, and then we'll locate it properly, sort of like we did with the circles. I'm going to create a vertical line, and the exact placement on the sketch right now is not critical. I'm going to click to select that line, and over in my sketch palette, which we haven't really talked about before, but this allows me to set some features to sketch lines and curves. I'm going to click on this construction toggle, and that's going to turn this to a dotted line. A construction line allows you to base features off of that line, but it itself will not be included in an operation like an extrude or anything like that. So it sort of makes the line invisible. It's kind of a way to look at it. Visible but invisible, if that makes sense. And we need to look at that at the center of the part. So if I click one of my key lines on the part here, this is a 23 millimeter width interior pocket. So this line needs to sit at a point that is 11.5 millimeters in the center. Okay. Or I can set a constraint that locates this line at the midpoint of that line. So let's try that. Let's click on this line to select it. And then I'm looking up at my constraints here. They've moved some of these recently, and I want to find, I think symmetry is the one that I'm looking for. I'm going to use the symmetry tool and click on this line. Nope, that didn't do it. Midpoint, that's what I'm looking for. Okay, so I'm going to choose this line, my construction line. I'm going to choose constraints, choose midpoint, and then I'm going to click on this line right here. And that snapped my construction line to the midpoint of this cross line. So now we can try to use our mirror operation. So the way that I'm going to do that is I'm going to choose all of the, I'm going to select all of the features that I want to mirror. So I've got my rectangle flange outline and the two mounting holes. I'm going to go to the Create menu. I'm going to choose Mirror. You can see I've already got my 6 objects selected. I'm going to click on Mirror Line, and I'm going to choose the center point. I'm going to click OK. And you can see that I've now got that flange mirrored across the center line. So it's showing up in the identical and opposite position on the other side. Now, I'm not sure that that actually saved me a lot of time in terms of the number of clicks, for example. But if you're creating a complicated feature, mirroring it can save you time, but also it can ensure that the features that you're creating on the opposite side of your part really are equal and symmetrical. I'm going to click Finish Sketch, go back to my 3D view, and now using the Extrude tool, I can extrude these up to a thickness of about 3 millimeters. Okay, so the model so far is here on the screen. It looks pretty much like the sketch, which is a good sign. So we're going to save our work. We're going to export it for printing. So if you right-click on the top level item in the browser and choose Save as STL, you can select your item, click OK, and it'll ask you to save it. We'll move this over to the printer, print a copy of it, and test the fit and see how we did. Okay, so I got the part back from the printer, and it looks pretty much like it did in the diagram, so you know that's a good sign. And let's check things out. Okay, well, the first problem is that I didn't account for where the wires exit from the servo, but that'll be an easy fix. And so that means I can't slide the servo all the way into the bracket, but since the mounting holes are symmetrical, I can flip it upside down, and I can see that the mounting holes line up perfectly. They're probably too small for you to see here, but it looks like the mounting holes are great. So I can't guarantee this, but I believe that if we add a cutout for those wires to pass through, I think this model will be a success. So let's go ahead and add that. I'm going to measure in from the bottom. It looks like the wires start coming out at about 4 millimeters, and we'll give it about 2.5 millimeters of space. So back in the modeling environment, we'll do a new sketch. We'll create that sketch on the front face here. And I'm going to create a rectangle. I'm going to make that rectangle the full width of this wall, and I said the height was going to be 2.5 millimeters. Nope, that's not right. Let's try that again. Two and a half millimeters tall. And then again, I'm going to use a dimension to set this cutout 4 millimeters away from the bottom. I'll end that sketch. And then I will use the extrude tool to make that cutaway. Now, there's a bit of a compromise here. We haven't talked previously about designing parts for convenient 3D printing, making them so that they don't require support material, that sort of thing. If I do this cutaway, I'm either going to have to print it with supports, or I'm going to have to reorient the part in another way so it prints without this overhang that I'm creating, but that's okay. We're going to address designing parts specifically for 3D printing in a later video. For now, I'm just going to make sure that I'm extruding this past the midpoint so that I've got clearance for those wires. I'm going to save that part, and I'm going to print it again, and we'll see how I did. Now this time when I print it, I'm going to lay it down so that that cutout that I just created is facing up, and if I'm lucky, it's going to print without supports. We'll see how we do. Okay, so here's version 2. You can see the cutout that we added in the last revision. Let's see how we did. The wires pass through neat. Flanges bottom out. It's flush on the bottom. And it looks like our mounting holes line up. Let's just double check that. I don't know how well this is going to go, me putting a screw in for the first time on camera, but I'd say that went pretty well. All right, I'm going to call that a success. Okay, so I think that's going to do it for this video. In the next one, we're going to talk about revising parts further. We touched on that a little bit today, but we're going to go a little deeper into iteration and revising parts. And we're also going to talk more about constraints and dimensions and the important parts that they play in editing and revising parts as well. And we're going to talk a little bit more about using construction geometry effectively. We used it a little bit today when we mirrored that feature, but there's a lot more you can do with construction geometry, and they really help you if you ever need to create a sketch in an, sort of an unusual location, like standing out from a curved surface or something like that. So stay tuned for that. I'll see you soon.